This is our planet. And no, this isn't some mistake. What you're looking at really is Earth, except you're seeing it the way it was 466 million years ago. There's a giant ring system that orbits it, similar to the one that currently surrounds Saturn. Billions of rocky fragments slowly circle the planet, forming a shimmering band in the sky. According to one hypothesis, these rings could have existed for tens of millions of years, and their emergence may have triggered a chain of extremely destructive events. They cast a shadow over the Earth's surface, affecting the planet's climate. Temperatures dropped, glaciers advanced, ecosystems began to collapse, and the planet shook from powerful surface impacts. Some scientists believe that this was when the first of the 5 largest mass extinctions occurred. But how could Earth have developed rings at all? What was happening on the surface when this massive rock ring loomed overhead? And what would it be like to find yourself at each time when nearly all life on Earth was almost wiped out? This is one of the largest and most destructive events in the universe. A supernova explosion. When a massive star reaches the final stage of its life and can no longer resist its own gravity, it collapses into a black hole, releasing energy equal to the light of an entire galaxy. Part of this energy, known as gamma-ray burst, is a narrowly focused beam of pure radiation that pierces through space at the speed of light. And it's heading straight for Earth. According to a theory proposed by astrophysicist Adrian Mellett and physicist Brian Thomas, the first mass extinction on our planet began 445 million years ago, at the exact moment this invisible stream of cosmic energy reached the upper layers of our atmosphere. Just 10 seconds of radiation turned the sky into a global chemical battlefield. Gamma rays literally tore apart molecules of nitrogen and oxygen. The sky began to change rapidly, turning dark brown and filling with dense toxic smog that blocked sunlight and caused catastrophic acid rain. But the main threat was invisible. The ozone layer, our only shield from the hostile cosmos, was essentially ripped open. Scientific models show that the planet instantly lost about 40 to 50% of its protection. That was enough for levels of deadly UVB radiation to triple, causing fatal DNA mutilations, sterilizing the ocean surface, and completely destroying the most important foundation of the food chain, plankton. However, the widely accepted theory you'll find in any textbook says that the mass extinction of this period was caused by a sudden ice age and a drop in global sea levels. But this raises another question. How do you trigger such rapid and global cooling in such a short time? The answer may surprise you. This asteroid is dozens of times larger than the Chicxulub asteroid that wiped out the dinosaurs, and it's on its way to Earth. But there'll be no collision. Instead, something far more unique is about to happen. As it passes a critical point known as the Roche limit, Earth's gravity begins to stretch its rocky body like Play-Doh. The rock cannot withstand the immense internal stress and breaks apart into trillions of fragments of various sizes. Instead of a single destructive impact, Earth undergoes something entirely different. These fragments arrange themselves into a clear, majestic, and deadly structure along the planet's equator. That's how Earth got its rings. Not unlike the rings of Saturn, but formed from the debris of our would-be destroyer. Professor Andy Tompkins from Monza University, actively studying this hypothesis, found geological evidence. 466 million years ago, the rate of meteorite impacts on Earth increased by 100 times. Massive chunks from this ring system constantly fell out of orbit, tore through the atmosphere, and slammed into the surface, creating fiery chaos. But the rings resulted in more consequences than impacts and cataclysms. They also created shadows on Earth. A vast arc of cosmic dust and rock blocked vital solar heat from reaching the tropics. Temperatures rapidly dropped below freezing, triggering one of the most severe ice ages in history and effectively freezing life in the ancient seas. The creatures and organisms that somehow survived the radiation burn from the gamma ray burst found themselves trapped in a gradually freezing world. Earth continued to actively cool while the rings slowly rained down onto the surface over millions of years, leaving behind scars in the form of craters and scorched wastelands where life once thrived. It's worth noting that we still can't definitively say whether Earth actually ever had rings or whether its atmosphere experienced a gamma ray burst. Nevertheless, these hypotheses remain among the most compelling scientific explanations for the events that took place on Earth during that time. In these cooling, radiation-poisoned waters, the creatures that had dominated the planet for millions of years began to die. The first to take the blow were true giants, known as Camaraceras, squid-like creatures 20 to 30 feet in length with long conical shells. They were followed by trilobites, whose hard shells that once protected them from predators proved useless against invisible radiation and sudden cold. The ocean floor gradually turned into a graveyard of our distant ancestors. Armored fish like Astraspis, whose bony armor couldn't save them from climate chaos. Even in the water column, life was fading. Colonies of planktonic graptolites were literally burned by ultraviolet radiation, and ancient coral reefs turned into lifeless white skeletons. The first great empire of life was collapsing. After the mass extinction, Earth lost nearly 85% of its living organisms. It seemed that life was slowly returning to its normal rhythm. But this was the calm before another catastrophe. This time, the threat did not come from space. It was Earth itself that created something that would ultimately begin to kill anything alive. The ferocity and strength of this predator would rival any shark living today. Its appearance alone inspires fear, as though declaring it as an almost perfect killing machine. It's a representative of armored fish that lived during the Devonian period 370 million years ago, known as Dunkleosteus. It earned the rightful status of a true monster. Instead of teeth, it had razor-sharp, bony plates that sharpened against each other every time the jaws closed. The pressure of its bite could reach 2,200 pounds, and the size of this creature is just as shocking. It reached up to 33 feet in length and could easily swallow a human whole. This is the absolute apex of the Devonian ocean food chain. But the time of this predator on Earth is limited. Right now, it's desperately trying to draw oxygen using its gills, flailing sharply, but it seems there is none. Without realizing it, Dunkleosteus has ventured into what is known as a dead zone, where oxygen in the water is almost entirely absent. At this time, there are vast numbers of these dead zones in the ocean, and over time, they're becoming more and more commonplace. Strangely enough, the cause of this anomaly lies on land. At this very moment, Earth is undergoing its second mass extinction, and the culprits are trees. The Devonian period gave rise to the first large-scale forests in history, but they turned out to be a kind of biological weapon. Trees like Archaeopteris began to aggressively colonize land. Their roots acting like powerful chemical drills, they broke through stone, released acids, and practically ground rock into dust to reach minerals. As a result, rains were washing enormous amounts of phosphorus, nitrogen, and other substances into rivers. The rivers carried all of this into the ocean, where it triggered complete chaos. As soon as these substances entered the sea, algae began to bloom en masse. The water surface would subsequently be covered with a dense green layer that blocked sunlight, The algae quickly died, tons of organic matter rotting in the water. Bacteria that rushed to decompose this mass started consuming all the oxygen in the water. The ocean turned into a huge bowl of toxic soup, where breathing was now impossible. This process killed indiscriminately. Along with Dunkleosteus, Titanichthys also perished. This was another giant of that era, reaching 25 feet in length. A massive creature whose behavior was similar to a modern whale shark. But even its enormous size proved useless against invisible suffocation. Creatures living on the very bottom of the ocean were no better off. One of them was Bothriolopis, a peculiar fish covered in a heavy shell made of bony plates, as if encased in natural armor. Its front fins looked like short armored limbs that it used to brace against the mud and carefully move along the ocean floor. It wasn't a fast predator and could not compete with the giant fish of the Devonian seas. Instead, Bothriolopis survived thanks to its armor, slowly crawling along the seabed, sifting through sediment in search of food. Interestingly, Bothriolopis fossils suggest that it had organs resembling lungs and could breathe ordinary air in the shallows. But even this evolutionary trick could not save this species. When the entire ecosystem collapses, there's nowhere to hide. In the shallows, where the water was turning toxic, the first true pioneers of land fought desperately for survival. These were the early temnospondyli, creatures that resembled giant salamanders with powerful crocodile-like jaws and distinctive wide, flat skulls. One of the most notable representatives of this group was Ichthyostega, reaching 5 feet in length. Its body was covered with small bony scales and massive limb fins that allowed it to haul its weight onto land, overcoming gravity. The rib cage was reinforced with overlapping ribs that protected the lungs from being compressed on land, while its tail retained a fin for maneuvering in water. Its head had complex sensory channels that allowed it to detect even the slightest environmental changes. But even this level of biological complexity proved powerless. The decay of Archaeopteryx forests and toxic runoff turned coastlines into sticky, oxygen-deprived traps. These amphibians suffocated and died in rotting swamps, losing access to clean water and food. And so, life on land accidentally suffocated life in the water. The Devonian oceans became vast graveyards filled with decaying bodies. Around 70 to 75% of all species perished. And yet, life on Earth persevered, even in spite of this slow suffocation. It adapted to the new world, unaware that the most massive and pervasive extinction in its entire history still lay ahead. This is arguably the most terrifying day in the lifetime of our planet. If you found yourself here at that time, the first thing you would want is to immediately return to the familiar, comfortable Earth with its fresh air and predictable climate. But right now, you're witnessing the height of the Great Permian extinction, which began 252 million years ago. You're surrounded by a dense yellowish haze. White ash falls slowly from the sky, covering the ground with a layer of dead dust. The air here is heavy, hot, and corrosive. Every breath burns your lungs. But the first thing that would truly knock you down is the horrific, nauseating smell. Everything reeks of rotten eggs. This is the smell of hydrogen sulfide, the gas that became the official death signature in this era. This world is reigned by an ominous silence. You can barely hear animal sounds, as life is on the brink of complete extinction. The cause of this planetary hell was a region we now call the Siberian Traps. It would be misleading to call the event that took place there a series of eruptions. It was a true geological apocalypse, difficult to compare with anything else. These scenes were recorded in 2018 during powerful lava flows from the Kilauea volcano in Hawaii. This event went down in history as one of the longest documented eruptions of the modern era. It lasted almost 35 years, but this is nothing compared to what happened 252 million years ago. A territory more than half of Europe in size split open, turning into a sea of boiling lava. And this fiery chaos lasted not for decades or even centuries, but for hundreds of thousands of years. Volcanoes released trillions of tons of carbon dioxide and methane into the atmosphere, creating the most intense greenhouse effect in Earth's history. As a result, the planet warmed by an astonishing 8 to 10 degrees Celsius. While on land this was a case of unbearable heat, in the ocean it was a death sentence. Water temperatures in the tropics reached 40 degrees Celsius. At these temperatures, proteins in the cells of living organisms began to break down. The ocean started losing oxygen, entering a global stage of ocean anoxia. But then, something even more horrifying happened. In the lifeless hot water, anaerobic bacteria began to multiply uncontrollably. The byproduct of their activity was hydrogen sulfide. Huge bubbles of this toxic gas rose from the ocean floor, poisoning the water and bursting into the atmosphere, turning the sky into a toxic dome and creating that pervasive smell of rotten eggs. This saber-toothed predator is called Inostrancevia, and it represents the peak of evolution at that time. With its powerful fangs and speed, it had no rivals. At the height of up to 4 feet and a body length of 11.5 feet, its size and teeth made it nearly unstoppable. But no fangs can save you against air that has turned poisonous. Its days were numbered. Along with Inostrancevia, almost all life perishes. The scale is staggering. 96% of all marine species and 70% of land vertebrates died out. This is the only known time in history when even insects went extinct on a mass scale. The ozone layer, damaged by volcanic gas, was partially destroyed. Intense ultraviolet radiation was grilling the surface, finishing off those who had survived the toxic haze. Millions of plants died, and their spores and seeds were sterilized in the soil. But then something even more astonishing happened. Geological layers from this period revealed what is called the coal gap. This means that for millions of years, forests on Earth were simply absent. The planet turned into a barren wasteland. Among this total desolation, only a few managed to pass through the narrowest opening of survival. One of them was Lystrosaurus. This strange herbivore with a powerful beak and the ability to dig burrows proved incredibly resilient. There were times when Lystrosaurus made up 95% of all land vertebrates on the planet. Almost everything perished. Massive Scutosaurus, armored herbivores up to 10 feet long and weighing over 2,200 pounds, suffocated in the toxic haze. Their heavy, bony armor was useless against oxygen deprivation and heat. Along with them, the Gorgonopsids vanished too. These saber-toothed predators, such as Inostrancevia, reaching 11.5 feet in length and weighing around 660 pounds, could no longer find sustenance in the scorched wasteland. At the same time, the oceans witnessed the end of the trilobites. They'd survived 2 previous mass extinctions, but finally succumbed to the hydrogen sulfide catastrophe. The Permian extinction marks the moment when Earth came closest to a total annihilation. It was a hellish climate where the smell of sulfur and suffocating heat were the norm for millions of years. Yet life is remarkably stubborn and adaptive. After this apocalypse, life rose from devastation to create a world of the greatest giants the planet has ever seen. However, their triumph would also be cut short. While dinosaurs were only beginning to take over land, deep within the Earth, another methane bomb was already ticking, ready to erupt at the first opportunity. The supercontinent Pangaea was a single colossal landmass containing all of Earth's land. This is the world as it was 200 million years ago, but on the planet's surface, a true chaos is emerging. The great continent has already started to slowly break apart, and this is where the Triassic-Jurassic extinction begins. At that time, it wasn't the dinosaurs that ruled on land, but other equally formidable reptiles. This giant predator, reaching up to 23 feet in length and over 4,400 pounds in mass, is known as Roisuchia, a land-dwelling relative of crocodiles with powerful jaws and massive teeth. It was a true nightmare of the Triassic. Nearby, there are Atosauria, armored herbivores about 13 feet in length with backs protected by massive bony plates. But their era is coming to an inevitable and violent end. They too will fall victim to this mass extinction. Beneath their feet, the Earth's crust groans and cracks. A massive rift dividing what will become the Americas, Africa, and Europe turns into a hellish conveyor of molten magma. This is the Central Atlantic Magmatic Province, one of the largest volcanic systems in the planet's history, covering more than 4 million square miles, slightly larger than the entire United States. A series of powerful eruptions released billions of tons of sulfur and carbon dioxide into the sky. The air turned into an acidic haze, but the most devastating blow was hidden in the dark, cold depths of the global ocean. Scientists propose the alarming Cathrate gun hypothesis, which suggests that there may have been a special form of ice on the ocean floor trapping methane under immense pressure. This gas retains heat about 30 times more effectively than carbon dioxide. When ocean water warms to a critical point, this icy shell begins to break down. Methane escapes into the water and atmosphere, causing the planet to heat even more rapidly and subsequently destroying vast amounts of life in prehistoric oceans. Most ancient reptiles, including Roisuchia, were not able to survive this greenhouse collapse. Among the perished, there were other unique species, including Phytosauria like Redondosaurus, averaging 21 feet in length and weighing around 2,600 pounds. Despite their resemblance to modern crocodiles, these predators were a separate branch of reptiles that completely died out, unable to withstand water acidification and the loss of their usual prey. Alongside them, giant amphibians like Metoposaurus, weighing up to 1,000 pounds and reaching 10 feet in length, also died out. These massive creatures with flat skulls once ruled shallow waters, but drying rivers and rising temperatures turned their habitat into a deadly trap. At the same time, dinosaurs coped with these conditions far more effectively. The key was in their unique physiology, a complex system of air sacs that allowed efficient breathing even in thin, toxic air, and an upright posture that gave them an advantage moving around. The Triassic extinction effectively cleared the stage for an evolutionary race, giving dinosaurs their great opportunity. Over the following millions of years, they would grow to unprecedented sizes, spread across every continent, and become the undisputed rulers of the planet for nearly 135 million years, dozens of times longer than humans have existed. But this evolutionary triumph would be destroyed in a single moment. One of the most devastating events in Earth's history is approaching. You know it as the asteroid impact that wiped out the dinosaurs. But how well do you really understand what happened? Today, thanks to modern research and advanced technology, scientists have reconstructed a minute-by-minute account of one of the most terrifying days in the history of our planet. How powerful was the asteroid impact? What did the dinosaurs experience in the first minutes and hours after the catastrophe? And, most importantly, could something like this happen again in our future?